Hello, it's me, Johanna, and I'm back to making math videos again. So today we are doing 1.5 and 1.6. I will continue to do it in the format that I made the 1.3 and 1.4 video because I thought it worked quite well. You can tell me in the comments if it doesn't. So we will begin with 1.5, which is the binomial theorem. To be honest, this was probably the part I hated the most of this chapter. Obviously, this chapter really isn't that bad. This is just chapter 1. But still, this part is probably the worst out of the other parts because it's harder to understand what it actually is. So a binomial is a simplified algebraic expression of the sum or difference of two terms. Now, that just sounds like words to me. I don't know what that means. But essentially, you use the patterns you can find to expand the brackets. You're doing expansions. So to understand how this works, you have to know what Pascal's triangle is. So Pascal's triangle works like this. So there's a 1, and then the next row there's two 1s. Then the next row there's a 1, then a 2, then a 1. So basically the pattern here is that everything going down is how you add up the two 1s above. So as you can see, the outsides of the triangles are just 1s because on top of that there's just a 1 and on the other side there's nothing. But if you look at the second row, there are two 1s, and if you go to the third row, in between those two 1s there's a 2 because on the row above those two 1s make 2, so it becomes a 2. And then if you look at the fourth row, you will see that there's a 1 and then a 3 and then a 3 and then a 1. And this is because a 1 plus a 2 makes a 3. And so on and so forth. And it keeps going down like that. So there are different combination notations that you need to know. These are either when it's a bracket and n is above an r, or when it's a c and there's like a small n and a small r in different ways. So n is the number of objects available, meanwhile r is the number of objects you want to choose. So what this essentially means is that if they ask you for c, let's say it's c and then the n is 5 and the r is a 3, then you are actually looking for whatever number it was plus 1 when it comes to the row of the triangle. So it would be, if it says 5 for the n, it would mean the 6th row. And if the r is a 3, then it would mean the 4th term. Now, I don't have the 6th row written down on this paper, so obviously that probably wasn't a smart choice, but hopefully you can understand. Let's say it's the 4th row, then you would know to go down to the 5th row and then look at the 4th term, which would be a 4 then. So essentially you just look at those numbers and then add 1 to it to figure out which number to use in Pascal's triangle. So there is a formula you can use, which is quite confusing. It is n and then an exclamation mark divided by r exclamation mark times n minus r exclamation mark. Now you might be wondering what an exclamation mark means. This is a factorial, and basically what this means is that you take any number and then, so if it's a 7 exclamation mark, that would mean 7 times 6 times 5 times 4 times 3 times 2 times 1. But if it's 9 exclamation mark, it means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Hopefully that explains what the exclamation mark means. However, I do not really use the formula that much. I mostly do it the long way, which sucks, but yeah, you know. And then there's also a formula for if you're finding a single term in an expansion. So what this means is that instead of finding the entire expansion, the question might ask you, can you find when the expansion where there is x squared or something. You know, they might ask you for like a specific part of the expansion. And now to do this, you use this formula, which is if it looks like, in brackets, a plus b to the power of n, then you can use this formula, which is, so the combination times a to the power of n minus 1 times b to the power of r. At least for me, the only way to actually wrap my mind around these formulas is using them, because they're quite confusing when you just look at them like this. I will give an example, though, to explain how the binomial theorem actually works, because I feel like it doesn't really help for me to sit here and explain it. It's better if I show you. And then that is all for 1.5. Now I will show you an example to make this even clearer, but for 1.6 is about proofs. And really all you have to know here is that if the left-hand side equals the right-hand side, then you have proved that they equal each other. That's all you have to do. You just have to put everything on the left-hand side to equal everything on the right-hand side. And a rule when you're doing an algebraic proof is that you can't move anything from the left-hand side to the right-hand side. You have to keep them on their own sides when you're doing a proof, because you're not solving the equation, you're just proving it. So for the binomial theorem, I will be taking an example from 1n, question 1, which was to expand x plus 5 in brackets to the power of 4. So because this number is 4, that means we're looking at the fifth row of Pascal's triangle, which is 1, 4, 6, 4, 1. So to find this first term, what you do is you take the power and put it to the x, and because the 4 is on the x, there is nothing on the 5. So this one is just x to the power of 4. Then for the next term, you have x to the power of 3, and then suddenly there's a 1 in front of the 5. But this is where the triangle comes in, because for the first one, it was times 1, which means that nothing really happens. But for the second one, it's times 4. So then you would have to do 5 to the power of 1 times 4, which is 20. And then you continue like that, so on and so forth, until you get to the other side where there is the power of 4 on the 5, and there is 0 powers on the x. Hopefully that made sense. You might have to pause and look at this for a while. Here is just a further explanation to how I did the third part of the expansion. So here you look, it's the third number, so that's a 6. So it's 6 times, and since this is the one where there's x squared, which means there's also 5 squared, because it has to equal to 4. And then you just work that out. You do 25, because that's what 5 squared is, times 6 times x squared, which ends up being 150 x squared. Again, this is sort of confusing, so you might have to look at this a couple times to figure it out, but hopefully that explains something. For 1.6, I will be using an example from 1p. I will be using the example that is 1p and then the second question, which is that prove that, in brackets, x minus 3 to the power of 2 plus 5 equals x squared minus 6x plus 14. So now you have to remember with proofs, you can't move anything on the left-hand side to the right-hand side, and you can't move anything from the right-hand side to the left-hand side. Here I just put a friendly reminder that when it says x minus 3 in brackets to the power of 2, it doesn't just mean x to the power of 2 minus 3 to the power of 2. No, it means that you're doing the entire thing in the bracket times itself. So that's just a friendly reminder. So then you work that out, and you add them up, and you simplify what you just found. And then suddenly, oh my god, look, they equal each other. Wow, great. And boom, you proved it. That's pretty much all there is to that. Seriously, the proofs part is very, very simple. So thank you for watching. This was the last video for Chapter 1 in the IB Maths AA Standard book. Please feel free to subscribe, like, comment, and follow me at Johanna Frennert on Instagram if you feel like it. You don't have to. Goodbye. I hope you learned something.